In addition to the relational operators that we just saw, greater than, less than, greater than or equal, less than or equal, 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 not equal, we can also use something called logical operators. And logical operators help us create more complex expressions. So I can use the and, to ampersands, meaning and. I can use two vertical bars, which mean or, and those two vertical bars, if you look on your keyboard, they are located below the backspace and above the enter key. And you would use shift to use them because they are like at the top of the key. And then exclamation mark next to anything means not. Now, let's think about the meaning of an and or an or. Okay. Now, let's assume that I tell you to get a good grade in my class, that you need to, or to get an A in the class, you need to pass the class, get a passing grade in the class, and you have to have perfect attendance. Okay, so those are my two conditions for actually passing the class. So if you get a passing grade, but you don't show up, I am not going to let you pass the class. Okay, so this is just an example. It's not true, but as an example, if you get the passing grade, but you don't have perfect attendance, my condition was that you had to have a passing grade and perfect attendance. You don't have a perfect attendance, so you're not going to pass. What if you don't have a passing grade, but you did have good attendance? Well, again, there's one condition that you didn't satisfy, so you wouldn't pass the class. Of course, if you don't pass the class, you don't have a passing grade, and you don't have perfect attendance, then there's nothing that you satisfied. So in that case, definitely you won't pass. But if you do have a passing grade and you have a perfect attendance, then in that case, you will pass and pass the class. So here we see that the and operator can be used to build expressions where you want many certain individual expressions to happen. So it's kind of like if you have a child and you tell them, if you finish your homework and you clean your room, then you can play and watch TV. Well, if they cleaned their room and they did their homework, you'll let them watch TV. But if they don't clean their room, even though they finished their homework, you're going to say, no, go back and clean your room first. If they cleaned their room but didn't do their homework, you're going to send them back and say, no, you have to do the homework first. So with the and operator, the two ampersands, every individual piece in your expression has to be true. And if all of them are true, then your whole expression evaluates to true. The or is a little different. Here, for example, if I say you're going to get a gift if you pass the class or you have perfect attendance. So if someone passes the class but never shows up, yeah, they'll get that gift. If they don't pass the class but they did have perfect attendance, they'll get a gift for at least attending. If they passed the class and they had perfect attendance, definitely they'll get a gift. The only way they won't get that gift, the only way this expression will evaluate to false, is if both parts are false. So this person didn't pass the class and didn't have perfect attendance, so definitely they don't deserve a gift. So we see that with the and, you have to have all parts of the expression to be true for the whole expression to evaluate to true. With the or, those two vertical bars, the or, either one of them has to be true. So as long as one of them is satisfied, you're okay. So as long as one of them here, this was true. In the perfect attendance here, it was true. In the last one, they were true. So in all these three cases, you got true. The only way it would give you a false is if neither parts of the expression gave you true. The exclamation mark just goes to an operator, to an expression, and negates it. So if you have something that's true, it makes it false. If it's false, it makes it true. Let's see an example before we talk about short circuiting. So here, let's look at those two numbers that we have been asking the user for, the numerator and denominator, and let's see if they are maybe big. So if I'll say, for example, if numerator is greater than, or let's check if they are negative. So if the numerator is less than 0 and the denominator is less than 0, then I will say system.out.println, although numbers are negative, answer is positive. Okay, so here this sentence, this statement will get only printed if both the numerator and the denominator are negative. So if I run it with negative numerator, -2, -5, I get that sentence printed. Okay, and I'm just going to comment out the code below it so that it will be easier for us to see whether it got printed or not. So now it's going to be the last statement in our code to get printed. Now let's run it again. And this time I'm going to give different numbers that are, you know, if both of them are positive, I don't get it. If one of them is negative and the other is positive, I still don't get it. So here I only get it if both of them are true. Now let's write another one and say if n is less than 0 or d is less than 0, I'm going to say system.out.println, one of the numbers was negative. Let's run it again, and let's just put only one of them. So if I make the numerator negative and the denominator positive, I get that message. Why? Because because it's an or. Only one of these have to evaluate to true. If I run it and do the opposite, the denominator is the one that's negative, I still get it. If I run it and I put both are negative, I still get it, because the or means at least one of them is true. Okay, so that's how you would do an and an or. Now there's something called short circuiting, which basically says that in some circumstances we might not have to test the whole expression. So for example, let's come here and let's run this code, and let me put a denominator of -10. Okay, now the code is going to come here eventually, and it's going to check, is n less than 0? Is -10 less than 0? The answer is yes. So it's going to have to go and check what the denominator is to see, you know, if this is going to eventually give me true or false. But if I come here and I see that n is less than 0, -10 is less than 0, yes, true. I already know that this part is true. Does it matter what the d is? It doesn't matter. Whatever denominator I give you, you know that this statement is going to get printed. You know that it will print one of the numbers was negative because you already saw one of them. One of them is already negative. So it is guaranteed that this statement is going to get printed. So in that case, the computer, the JVM, doesn't have to go check what's after the or. It's not going to go check what the denominator is because it already knows that the first part is true. And with an or, if you have one part is true, the whole thing evaluates to true. So that's called short circuiting, when the JVM decides that I know the answer to this Boolean expression without evaluating the whole expression. So I know that no matter what I put here for the denominator, I'm going to get this one of the numbers was negative message. Okay, so with an or, if the first part of the expression evaluates to true, it will not go and check what the rest of the expression is. This is called short circuiting. Now the opposite with an and, if I come here and I say the numerator is 8. Now, is 8 less than 0? The answer is no. So if n is not less than 0, that means there is no way for this expression to be true, because this is an and statement. And with an and, all the parts have to be true. But I know I already have a false. There is no way. It doesn't really matter what D is. There is no way this statement is going to get called and executed. So no matter what I put for the denominator, I am not going to get this although numbers are negative message. So that is just what short circuiting is. Short circuiting says if you have an and the first part is false, there's no reason to check the second part. The whole expression is going to give you false. With an or, if you have an or and you have a true at the beginning, you immediately know that this expression is going to evaluate to true because you found your true. You found some part that is true. And that is just what short circuiting is. It saves the JVM some time and CPU time.